Hello guys, it's Timileyin Awodele here and welcome back to my YouTube channel. In today's video, I would like to talk about what I think it takes for somebody or someone to become a mechanical design engineer. A mechanical design engineer is someone who brings ideas to life. I love defining it that way. Someone who brings ideas to life. So the idea could be a consumer product. So the idea could be maybe industrial equipment. Basically, that's what a mechanical design engineer does. So your phone was once an idea. The iPhone 15 was once an idea. So a mechanical engineer is someone that designs what the hardware will look like, what the case will look like, what the frame of the phone will look like, how each electrical component inside the phone will fit in. So basically that's what a mechanical design engineer does. And I'm sure we see different designs of tables and different designs of so many things. So basically the 3D model of those designs is where the idea starts from. Then from the 3D model it goes to the next stage where it is either maybe 3D printed or fabricated through injection molding or CNC machining or any form of production method that wants to be used to produce that kind of material, that kind of product. So yeah, that's just like the summary of what a mechanical design engineer does. So they really need to take into consideration what the consumer wants, and they need to take into consideration a lot of things to make sure that whatever it is they are designing can be mass produced, because that's one other thing, mass production. So let's just get straight into the video for today. What I think it takes to become a mechanical design engineer. Okay, so the first thing I would like to say is that you don't need a special degree or any special certificate to be a mechanical design engineer. So you could be in any field of engineering. You could be in production engineering, industrial engineering, chemical engineering and mechanical engineering, and still be a design engineer. So but usually mechanical engineers are most of the people that go into design engineering full time, because it's more related to mechanical, and I think we all know that mechanical is a very broad engineering field. So basically you do not need any special type of degree for you to go into design engineering, but you need some basic knowledge of engineering manufacturing. And the next one is you need to learn some softwares. So basically the way I see the softwares and the way I tell people about the software is that see it as a tool, because basically it is a tool. That's just what they are. So there are some softwares. The most popular one for now is SolidWorks. For mechanical designs, SolidWorks is like the best one for now. While for architectural designs and all those other stuff, AutoCAD is still very good for it. But for students, Fusion 360 is like one of the best. Reason is because this licensing for SolidWorks is very expensive. But for Fusion 360 gives you free access for 1 year if you're a student, and you can renew it as much as possible. So I've been using Fusion 360 student package for like 2 years now. In fact, more than 2 years. Like it should be close to 3 years now, and I've been renewing it, and every time I renew it, it gets renewed for me. So yeah, I would recommend Fusion 360. So it's just like any other tool, like the way a graphics designer will use Photoshop and Canva for their designs, and the way a programmer will use VS Code for programming, and the way a video editor will use DaVinci Resolve or Premiere Pro for video editing. That's just the way all these softwares are. So I don't want us to see it as a very big thing that you require, a professional to teach you. No, there's so many resources on YouTube that you can take to just put you through on how to use these tools. And once you know the basic features in them, you can just transfer the knowledge from one design software to the other design software. So it makes it very interesting. What you've learned from SolidWorks, you can transfer it to Fusion 360. So instead of learning Fusion for like 6 months, in a month, 2 months, you will be good with it if you have the time to actually dedicate to learning it. Still in the line of learning, I think the major thing is you have to commit to lifelong learning, because there are so many updates that keep coming out on all these softwares. And the funny thing is that you've not even learned 20% of the old one, and another update will come out. So you have to just dedicate yourself to lifelong learning. I see a lot of people message me that, boss, come and teach me this, teach me that. But the truth is that I still have people I look up to. I still have people I learn from. I still look up to, all these guys and learn as much as possible from them. So you just have to dedicate yourself to lifelong learning, especially if you want to build a career out of it. So if it's something that you want to build a career out of, then definitely you have to be dedicated to learning, relearning, and unlearning. So that's just it. And the final one is that, as I've said earlier, you need to learn some basic engineering principles. So you don't need to be an engineer, but you need to learn some basic engineering principles. Don't be intimidated. They are not hard. So principles like design for manufacturing and design for assembly. So it's just a set of rules. I can call it a checklist that you need to check whenever you are making a design. Like some of it is when you are designing for injection molding. There are certain ways you can design for something that will be molded through an injection machine, and there are certain ways you can design something that will be 3D printed. So you have to put all these things into consideration. So you can just watch a few I don't have any video recommendations for now, or tutorial recommendations, but you can check YouTube and check some videos on design for manufacturing, DFM, and design for assembly, DFA. And another one is finite element analysis and computational fluid dynamics, FEA and CFD. So you don't need to learn this when you are just getting started, but as you progress with 3D modeling, you get to discover that it's actually an added benefit for you if you know about FEA and CFD. Because what FEA and CFD does is that by the time you design something that is going to be produced, so FEA allows you to simulate it in real time, how that product you have developed will behave in real time. FEA allows you to do that, so it will simulate the stress and the load that product can possibly be exposed to, and how that product will behave if it is exposed to those conditions. So that can make you to adjust your designs. CFD is for the fluid side of it. If you want to simulate how a fluid will pass through maybe like a pipeline or something, and if you want to do some heat check, how the material will react when it is exposed to some level of temperature and heat. Okay, so the last one is not the last one. I would have said the last one is material selection. Material selection. So you can just have a brief knowledge of different types of materials and the applications of the materials, how they are used, and all that. You just need a surface knowledge of this. It's usually the work of a materials engineer. I'm a materials engineer. So it's usually the work of a materials engineer, but you can just have a surface knowledge of this. Do you get? So just have a surface knowledge of material selection. And the last one is GD&T, geometric dimension and tolerance. This is usually more applicable when you do a design and you are sending it to a technician to produce it for you. So GD&T is just like those engineering jargons. I don't want to call them jargons. I just call them jargons. They're just like those engineering terminologies that you use to communicate dimensions and some informations with the technician that is going to produce what you've designed. So it's just like dimensioning, as the name implies, geometric dimensioning and tolerance. So basically that's what it does. You just need to know it so that you can communicate your idea more effectively to the person that is producing it for you. Yeah, and for now, yeah, that's all I have for now. So if there's any other thing you think I should include that I did not remember to include, yeah, you can just put it in the comment section below. And once again, I am Awodele, and I'm always rooting for you. Bye.